Welcome. I'm just continuing right off where I left off with us grabbing the bytes, and we're going to try and see what they say. So let's continue on, and then we'll try and exploit this service, hopefully, in this part. So I'm just going to use CyberChef again. I'm going to trash that recipe and say from decimal, because that's what it looks like. Looks like we have a post request. So post into diagnostics. Zoom in a little bit. Ooh, that doesn't look good. Oh well. So it looks like we post to diagnostics, HTTP 1.1, host, localhost, user curl, user agent, go HTTP client /1.1. Looks like we have status data, balloon ID, all that stuff, all that stuff. It just looks like it's then doing that process parse that we had identified. Doesn't appear to be anything else in this data field. If we come back to this, we can look at, there was one more piece that we had identified but we're really concerned with. If we come down to the posts, it was getting more data back. Maybe it was trying to hit a different web page. So we're going to actually be faster if we just run strings on it. Maybe there's different web pages hidden in here. Let's not do it in that client. Need to clean up my terminals as well. Strings diagonal client. Put that to less. Grep HTTP. Not grep, HTTP. HTTP /. It's giving us a lot of the internal HTTP garbage. HTTP /. Oh, :/, my bad. Remember we had that HTTP, so it looks like diagnostics is the only one that might be in here. There's HTTP chunked, but that's probably nothing. So what happens if we try to either get or post to diagnostics ourselves? Because we knew what happens if we do it through this. So we can do, over here, do sudo service ssh stop. That way we can come over here and bring back up our SSH forwarding. SSH to localhost, so tech I with the ID non-root at localhost. Oh, we need to reset our key again, or our expected host key. Yes. So diagnostics server is starting, so it makes sense that it's going to be posting to diagnostics now that we know that. So what happens if we try to get diagnostics? I shouldn't have pressed enter. It closed it on us. I was thinking that it would just give me a prompt of some sort, but that was a mistake. So let's get /diagnostics at HTTP /1.1. Method not allowed. So if we post to diagnostics, HTTP /1.1, page not found. I spelled diagnostics wrong. Post. So it looks like also that as long as we keep this open, it doesn't appear to close. As long as we don't put in a malformed HTTP request, apparently. So post to diagnostics, HTTP /1.1. Bad request. So error decoding status update. So it looks like we need some kind of status. So if we come over here, looks like we have this status. We're going to just copy all of this and clean it up a little bit. We'll say vim temporary status. Let's create a new page. I'm just going to get rid of all of it. Yeah, let's actually create as backups then. Copy temp status to backup status. So let's start with removing all of these system info. Maybe we can keep the status data because that appears to have been accessed. So it's trying to get the status update. Balloon ID, that was a fake one anyway, so we can keep that. System info, let's maybe just make this one empty. It's a little bit hard to identify where this last colon is. Let's just dump everything till the end. It's just JSON, so it should be able to be parsed emptily. try that. Cat back status. We can post to diagnostics. We're going to now need actually correct posting. So I'm actually going to start writing this in a script. Script.py. I'm going to do from pwn import everything. I'm going to use the pwn library, which means I need to install a pwn library. Pwn tools. If you don't know what pwn tools is, it's just a nice front end for sockets and SSH stuff. So this will make it a lot easier for us to connect. So we can do, we'll say s is equal to SSH, so we're going to SSH in, and we're going to say the host is equal to localhost. What else do we need? We need a user. User is equal to non-root underscore user. The key file, because we need a key file, is set to just id ed. I don't want to close that quite yet. ed2519. Kill that. I think we might also need to set this to raw equals true. So what raw is going to do is it's going to say when I SSH in, don't try and run any of your other pwn tools usual stuff to identify SSH information. Just treat this as a raw buffer and I'll deal with it. So now I'm going to create a shell. I'm going to say p for s.shell. We'll set the TTY, because we don't want it to create a TTY, to false. And if we do p.interactive, we can check to see how this looks. Script. So it looks like we just connected as a regular SSH client, and after a couple minutes, it should spin up. Oh, same device connection progress. It looks like we can only have one device connected. That's interesting. Didn't know about that one. But with that, we can now then do a p.read until. So we know it's going to spin up a little bit until it's ready. So we're going to read until it's ready. If it's not ready, then any data we send will probably just be sent to the void. So let's set up a HTTP request. So we know our data. So I'm going to say rec is equal to post at diagnostics HTTP /1.1. New line. Then we can add, not new line yet. We're going to set this actually to a format string and say content underscore length. Is it content underscore length? Content dash length. I have a version up and on the side. I can check real quick. Content dash length. It's actually all caps as well. Content dash length, because I don't want to have to fumble around this whole time. And then we can say this is going to be equal to the length of our payload, whatever payload we're sending. So in this case, our payload is equal to this string, that. And then we can even add our payload down here. Payload. We can send in our first new line there, and then our second one when we send it. p.sendLine of request. There's a chance that we also need to say what kind of type of content it is, and maybe even a user agent. This is probably actually easier done just copying this. So we're not sure what it's going to parse on, so it doesn't hurt to just copy it all. Just paste that. I already have content length. Doesn't really matter where it goes, but I'll keep it in line. Accept the encoding gzip. I think I have one too many new lines right there. And I think if all went well, we should be able to see what this returns. I wanted to do this by hand, but it's not possible, or it is possible. We just need to count this out, and I don't want to do that. So Python 3 script, run this guy. Could set the debug. Probably should set debug to see what it's at come with. Looks like we got a malformed HTTP request. I'm going to set context.log level to debug. I know there's a way to do it by command line, but I just prefer to have it written. Run it again. So it looks like we received the diagnostics server starting. We sent in HTTP, nope, we sent in this. Post to diagnostics, host, gzip, second new line, sent in that data, new line. I'm not quite identifying what's wrong off the top. Just taking a quick gander at my other script to see if I messed something up. I don't think I did. JSON. That should be right. Take a quick gander at it again. Oh, decoding status update, invalid curly bracket after object key. So do I have one too many curly brackets? So that should be for that one. That goes to that. That should just be the beginning one. Is there really too many? Maybe it doesn't like this one right here. Let me check back on the system info, see what it was. Yeah, it was a curly bracket. Maybe it didn't like the fact that it was empty inside. Let's try that, see what this runs with. It's going to fail right here, so let's just set this to an empty string. Run that. Server starting. Oh, we got some information back, actually. So it looks like JSON command and next command. Blah, blah, blah. Malformed HTTP request still. Oh, error nil. JSON encoded next command, error nil. So it means maybe there's no error. It still is saying there's a malformed. This could be the... Could be a secondary. Maybe I sent in too many new lines. Let's go to where we ran it. So it looks like we sent in balloon ID, system info, ID all zeros. That's not what we sent in. Oh, it's what we received. Command named blank, command args null. Then we received this JSON encoded next command. Let's check out this guy, see what that is. Copy selection. Come up here. We don't really need this anymore, but if we do, we can just get it right away. Oh, looks like it's just the same thing. But it's still saying malformed HTTP request, which is interesting. So server to client, ID that, command name that, malformed HTTP request. Okay, so what happens if we start to tinker with this request a little bit? What happens if we get rid of system info? Run it there. Let's actually clean this terminal before we run it. It looks like we got the same request back, malformed HTTP request. So if it is a malformed request, maybe we're just missing information or data. So let's add a little bit more back. So let's add memory info back, and then just add total. Let's see, where is the end of this guy? Total. Oops. Total closes right there. Yeah, I can send all that. Doesn't look like that's any really important stuff. Go back to our terminal. I'll keep that payload for now. We have a new payload now. Close this. Run it. Might even just comment this one out because I don't want this to affect anything. I don't think a new line is actually counted when you count the string length. It shouldn't be. It looks like we got the same response again. So maybe we're missing something. So let's look back at this guy. We know that there's a chance it sends us a command, but what does it do with that command after it gets it? If I scroll all the way to the bottom. That's not an error print. It's hoping to handling next command comes down here, goes to run main command. After it runs it, does it try and do anything with it? Start executing command, so OS execute. We have a printf done executing command. It looks like it's trying to log something. It's a weird offset. It looks like there's a timestamp of some sort right there. Oh, yep, time to format. Looks like it does another time to format, so maybe this is checking how long it took to run the command. Do a printf down here. Command begin at %v and then end %v, so yep, that lines up with what we were thinking. Command response, and then that looks like it does something there. Nil is interesting. Another nil. Slice byte to array. So I'm interested in this command response because it's not lining up with the other. It does look like a printf. I think that's what I'm looking at. That's actually not the one I'm looking for. Should be another command response somewhere, I believe. I think we could walk through this in GDB to identify possibilities, but let me do a quick string search. Search memory, we're going to look for, oh, didn't mean to make that beep. I'm not sure if you heard that beep. Command underscore response. Oh, it is right there. Search all. Is it only that one? Oh, so maybe it is actually this string still, but it's modified. Just not identifying it correctly. That is not the same string. I want my search back. I think I closed it though. Select search. Command underscore response. Search all. This guy. Where are you used? Right here. You're not used anywhere else then. Okay, so we know it grabs the response back, or it grabs a command response and prints it to us, the debug if it happens. We might go back to main to see if it goes anywhere else. Oh, shouldn't have done that. Need me to scroll all the way back down. Main print function, run complete. Because there's a theory that if it's going to run a command, it needs to tell the server at some time, like, hey, I ran this command, this is what happened. But I'm not identifying any location where it would be easily identifiable that there is that. Run. And I don't think agent responds with anything. After it gets exec v, it just exits. So it doesn't matter. We can actually look back at this guy, see if there's anything else we're missing. So let's see if there's any other parameters maybe at the bottom that we overlooked. Doesn't look like it. Looks like these are just PIDs. Memory, system info, balloon ID. So what happens if we remove system info? Now we're just going to start tinkering with the remote server. So we have a balloon ID. Let's just remove all of this. That should work. See what that does. Malformed HP request. It's weird that I might be sending a new line. Let's just do a send. it's still saying malformed. Something's malformed still. Maybe it doesn't like the new line there. I don't think payload would have a new line by default. Oh, there we go. Oh, I pressed an F. Yeah, that's going to be a problem. So get http://1.1. Yeah, that F really messed it up. So it looks like I didn't need to send a new line at all. It doesn't look like there's... So it looks like there's command name. What happens if we send it command name? Oops, missed a quote. JSON encoded next command. Doesn't look like anything really happened with that. Oh, so this looks to be the diagnostic server's debug, printing to us similar to how we printed to it. Right. Oh, what's this? Received status update without command response. So what happens if we send it a command response then? So what does a command response look like? There's a couple ways we could determine. We could try command response. I've got a hunch that this one won't work. But this is kind of this task is that we're going to be poking the server and trying to identify what it responds with and see what we returned with. So it receives status update without command response. So if we check out status update right here, it's all caps, camel case, or not camel case, but close. But when we're sending it, we're doing status underscore data. So maybe we need to do command as lowercase with an underscore in between. We actually might even need status. It's getting status update without the data, so it's seeing status data. I'm going to try command response. If that doesn't work, then I'll try command data, which doesn't really sound like something that would be logical. Received without command response. So we'll try with command data. Just enter. Command data. Could also be that the fact that we left it empty as an empty string. So we might have to go back through and try those again. Looks like we got without command response again. Let's try with some kind of JSON. We'll do hello garbage text. Because we don't know what it looks like right now. But we have a hint that there should be something there. Receive status update without command response. Let's try command response again instead of data. Command response. Looks like we got status update without command response. I think everything's been looking the same so far. I believe everything has been right. Just looking at my notes real quick. Because we could be messing up where it's expecting command response to be at the same level as data. And right now we have it nested. So let's move this curly bracket over. We'll go through both those test cases again if we need to. Check this out. This one looks different. So invalid length for command underscore response dot start time. So that one's new. So it looks like we need to set a start time. So it looks like the start time needs to be equal to 25 as well. Let's go over here. We need start underscore time. Start time, we don't really know ideally what it should be, but 25 characters. And this appears to be another Go binary since the layout's been similar. We can count these 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. It's pretty close to 25, so let's cut off the last one. You're also able to notice it in when we ran the binary locally. Not this one, don't need that one anymore. I don't even know where we ran it. Oh, it's this one. It has a similar timestamp. This one's just set to epoch because that's what the date time is set to, I think. Date. Yep, set to epoch. So that's a good hint at that's what our date or our string should look like. Let's clean this out. Send that, see what happens. Sadly, it takes a couple seconds every time. Invalid length. Command start time. Looks like our start time length is still wrong. Is it not 25 characters? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. Is it not start underscore time? Oh, start time. No underscores. Delete that. Run it again. We see the diagnostic server. This time we are missing an end time. Clean that up. Just going to copy this entire line. Paste it. Looks like we can do end time. I might do it a little bit in the future, just to make it look like it took some time. Not sure if that matters. See what we get back. It looks like open diagnostics var logs commands by IP 6474000224. Oh, looks like it's using our time. .json, no such file or directory. So it's interesting that I tried to open a file or open this directory, and then if you pay close attention, 64.7f is actually 100. 64 is 100. 7f should be 127.0002. That happens to line up very closely with our IP that was given to us. Right there, it lines up exactly. So maybe it looks like it's storing the logs based on IP and time that it's posted. Let's go back to this one. So what can we do with that? Interesting enough, it looks like it's based on the time itself. So what happens if we change the time? It was on 5233. 52, so that's 53. So it looks like it may be based on start time. So what if we set start time to something that's 25 characters long, but not time? I'm going to set this to test. Set the test variable. Make this a format string. Test is equal to ABCD. And then we're going to say test is then appended with the letter A all the way to times 25 minus the length of test. See what we can do with that. F string, oh, it doesn't like curly brackets in F strings, that's right. I'm going to change this up. We'll just close it here, add test, and then reopen it. I think I'm going to need quotes in here though. Run this. We're getting close to the final exploit, so hopefully this video is not too much longer. So A, B, C, D, A. Maybe it's still parsing based off of that time, so it didn't either didn't find anything or just didn't give us the error. Status update with command response. Reduce status update with command response. I'm not seeing anything similar to last time. So let's come back in here. Let's add a fake start time. So let's go 2024/01/05 space ABCD. So maybe it's using that space. Was it using the space last time? Let's scroll up to view. Looks like the space was, or the final characters were the part of the file name. So probably don't need the space. Let's try that. See what it comes up with. It looks like error, storing command response to this file name. No such file or directory. Interesting. At this point, you might try some different kind of payloads. So maybe we can do format strings, do %p. Since it's a Go, there's probably not a good chance that format strings will work. The only reason we think it's Go is because this output looks very similar to what our logging did when we ran it locally. So %p didn't do anything. I'm just going to close this now. S.close. Keep this interactive for later. Another thing we could try is path traversal. So if we'd go back, let's go back a couple directories, see what happens. Let's go back one directory first. Going back one directory, it appears oh, I closed it before I even read. I guess I still need that interactive. That makes sense. At that point, we were just sending data and it didn't come back to us. So this time it looks like it went back a directory and then went aaa.json not found. What if we did more backslashes? What if we did backslashes for the year as well? Not sure what kind of parsing it's enabling. What if we go back a bunch? We can't go more than 25 characters. 2, 3, 6, 9, 12, 15, 18, 21, 24. Yeah, that should work. See what that comes up with. Oh, this one's interesting. So it looks like it tried to write again, but instead of getting no such file directory, we got permission denied. So if we were to go back, those cancel out, those cancel out, those cancel out, those cancel out. Okay, we go back another one. Whoops. Another one, another one, another one. Looks like we tried to write to the diagnostics directory. What if we try to write to... we can go back. Let's get rid of 1, 2, 3. What if we try to... Oh, 4. What if we tried to write to by IP? 1, 2, 3, 4. So this should just go backwards through our IP. It doesn't look like we have enough path traversal to go back to root, the root directory. So it doesn't look like we could write to anything else there possibly. Looks like we have permission denied still by writing to by IP. What if we try to write to a garbage directory that shouldn't exist, such as ASDF /. See what this comes up with. It looks like we get no such directory. So that's kind of the path we're going to go forward now. Looks like we have an indirect file traversal into memory dump, or not dump, but like memory display. So we can kind of do a memory or path traversal and determine what directories exist by not being able to write to them. So if we do a 64, it should come back as permission denied, so we shouldn't have permission to write to that directory. permission denied. Then if we do a 65, it should say file doesn't exist, as 65 shouldn't exist in this case, where our subnet should always be within the 100. File directory does not exist. So that's our path forward, is we're going to go back a couple directories and then try and brute force to see what directories exist. You may be thinking that trying to brute force an IP shouldn't be possible, as there's 255 times 255 times 255 times 255 possibilities, but that's not quite true in the sense that we really only need to go directory by directory. We know the first one's going to be 64. I'm actually just going to set this up in a for loop. For x in range of, I could do 256, but it's not needed, as we know our subnet is 64.12, so it's at least going to be 64. So I'm going to do 64, starting at that, go to 256. I'm going to push all these to the right, and then I'm going to put F. This needs to be hex, so I'm going to do hex command at F, and then we don't want the first two characters, as that will be 0x. So now this will brute force all from 64, not 64, we want, 64, and then this is actually at 64. Weird coincidence that hex 64 is 100, and then we're starting at 64. But we're going to brute force all the way from 64 to 256, see what kind of directories exist. What we need to then read, we don't want p.interactive anymore. We can set close there. Do p.read until, what are we going to read until? There's something that always prints after that we can always count on showing up. This debugs are kind of bothersome because they kind of mess us up. It's either going to be no such file or directory or permission denied. We can guarantee that. So I might be able to read until server error. Can't just read until server error like this, because the server itself, when it responds, will actually give it stat. We could read until server to client body. I think that might be our best bet. So we do that, then we can print out P. It's going to print out a lot of garbage. We don't actually care about that. We're going to do check. We can then say if permission denied is in check. We can then say this one didn't exist. So we might actually want the inverse of that. Permission denied is not in there. Oh, permission denied. Yeah, that means it does exist. We're going to print X. And that's all we want to print. I'm going to turn off debugging for now, because it's going to be a little bit cumbersome. I think that might work. Let's run that and see what it prints out. Could have maybe added some debugging so we know what while we're counting through. F is not defined. Oh, didn't want this to be F. I wanted that to be X. Print this out. We got a failure on the read. Set the debug back. Run that again. See if it ran at least one time. Maybe just something's off with our loop or our print. Malformed MIME header. Looks like something went wrong with our first attempt. Oh, looks like we missed a /. That's important. Not sure why that would mess up the MIME header though. Interesting. Oh, don't do that. Let's add a / right here. Add that outside the curly bracket would be nice. This should print out with a lot of debug info again, but this will tell us whether the server is actually correctly responding and running in a loop. Still failed. Malformed MIME header. It's interesting that it's getting a malformed malm header when we were able to do it correctly by hand the first time. So what did we accidentally change within this request? P.interactive. Can set this test. We'll set this to 40 by hand. See what it comes up with. In fact, this 64 probably isn't needed. We just don't need to go back one directory, but I'm just going to leave it. Helps keep track of how far we are. I'm not seeing anything else that should be wrong. Try that. This should give us a permission denied because the directory 64, there's a good chance it exists, but I messed up our... I'm going to save this, undo everything, see what I accidentally changed. I wasn't using X anymore, was I? So let's see if this one runs. Okay, so that one runs. So somehow while going through this, so the fact that I used a format string, I don't think it should be. That p.read shouldn't matter. That shouldn't matter. X shouldn't matter. Let's do that. Change this to a regular again. Put that in. Malformed MIME header. Initial line host to localhost. Oh, yeah. Okay, tabbing this in messed it up. Because it's going to... The triple quote is treating this as direct content. Don't think there's anything there. Okay. That's what went wrong. Okay, now this one should possibly loop. I should have turned off debug, but we're going to check to see if it works. Oh, I think I have it set to interactive. Yep. So that should be fine. I'm going to turn off debug and see what gets printed out. So 68 was printed out, so 64 wasn't even one of them. It would have been nice if I added a counter of some sort to know whether it's still increasing. It's hard to tell how long it's taking. So I might actually kill this, add this so it just prints out X so we know we're not stuck on something, and then we can add the word hit right here. We know at least 68 was hit, so we can go up to 68. I'll run this again. Okay, so it's actually going at a pretty good speed. I just need to get up to 256. We also need to keep track of the ones that were hit, because that means we need to go further into those directories, or into those paths. Almost there. It doesn't look like any others were hit, which doesn't sound right. I think a couple more should have been hit. $68 definitely should have been hit, but just looking at my notes, there should have been a couple more. While we're here, we can just go deeper into 68. 68 in hex is 64 is 40, so 48. No, 44. I think 68, 64. Yeah, should be 44. This time we're going to go deeper, so now we start back at 0, because now we're in the third bit range, or third byte range. Go into this. Takes a little bit for it to spin up. We could build out a very extensive script that dives into everything, but I doubt that's needed. So it looks like 21 was hit. We could just sit through all 256, but just to speed this up a little bit, as this video is getting a little bit long, 21 is the only one in that subnet, or within that range. 21 would be 16 plus 55, so 15. Start this up again. I'm going to actually shrink down our corpus because I know I have predetermined knowledge of where this final byte is at. If I had to guess, I'm going to say something is wrong with our script within the first one as well, as we only got one hit within the first subnet. We should have at least gotten a hit with 127, I believe. Why didn't we get a hit? 15 should be 21. 10 should be 16. Oh, I know what I did wrong. Okay, so if we look back, let's print this out actually. Print test. We made a wrong assumption. So we made an assumption that this is all hex characters, which it probably is. But when it starts to get larger like this, you start to get characters as well. But there's probably a chance that these characters are supposed to be uppercase. We might be able to identify this if we connect once. I'm just going to do p.interactive exit. I think we just missed one tiny aspect or information in the fact that all letters are probably capitalized. Right there, we can see when it connected through 100, 127, it should be capitalized. So we just need to set the hex dot upper, I think. Whoops. Don't need that. Didn't mean to close my script. Run this again. I think dot upper is the Python method for strings. Yep, okay. So now we're printing the string out. Then we should get one more hit on this. We didn't. What did I mess up? So it should be 100, 68, 21, and then the last number is not procking. I'm going to turn on debug. There's a chance that the script is also missing something else. It's going to be a lot noisier though, sadly. So at this point we know that there should be one in this range. Well, we should know it's within the 256 range. We don't know exactly where. No such file directory, no such file directory. Where are we at? No such file directory. No such file directory. No such file directory. No such file directory. Nope. Nope. What should it be at? It should be up here a little bit. No such file directory. No such file directory. This one's different. Okay, so maybe the fact that we procced on this one actually didn't give us an error, so maybe we were able to actually save to this directory. So let's change this and say that if permission denied isn't checked, let's actually change this to no such file or directory to continue, or not in there. Not in there. Then we have a hit. I'm going to stop printing out this one. Oops. Run it one more time, and then that last one is at 243, so we should get a hit at 243. I just left the debug on. Uh, 243 hit. There we go. All right, so it looks like one of our IPs is at 100.68.21.143. We have two more to find, I believe. Or at least one more. Based on this, there should be at least two of them. So let's set this back to 0. Oh, I guess we set it back to 68. Because we need to run through that first one again where we messed up the 2-upper. Run it. I'm going to set the debug off now. Run this. Have a hit at 68. Have a hit at 76. That looks better. I'm going to let it run all the way through because there should be 127. Should be our last one. I'm not going to go down the route of 127 as this video is getting quite long, but 127 is just the jump box as a hit, which I think was created when we first connected. I think it just created the directory when we first tried to hit the server. So we have a hit at 100.127.0.2, most likely. We're not going to go down that path. 100.76, I believe. Check this, 76, when you go down that route. 76 should be 64, should be the closest, plus 12, so 4C. If I did that correctly. I'm going to go through this one now. I started at 68 on accident, but there won't be any in the earlier version or earlier numbers. In fact, could have started higher again. But I'll let these last two ones run out all the way just to give a sense of the process. Should be coming up on it. 241. Looks like we got a hit. We're going to finish that out. Nothing else in that directory. 241, there's a hit. 241 in hex. Heck, if I know that one. I can just do quick Python 3 hex 241 F1. Change this to F1. Run this again. I'm going to increase this again just so we don't have to wait nearly as long. Should still take a little bit to get to it. 50, 60, 70, 82. I'll let this finish just in case there's another IP that's on the same subnet or same /24. There was not, so 182. So we set this to 182. Cat script, and I believe those should be our answers. It wants the IPs. I don't know if it wants our jump box IP or not. Figure out how the devices communicate. Goal is to determine the IP address for any devices that connect to the same server. There should be two addresses, one for the down device, so we don't need that one, because that's our jump box. So it should be the two addresses, and if it's correct, something went wrong, scroll back down again. At least one of those addresses is not correct. Interesting. We gotta wait another minute. Maybe it did want the jump box ID or IP as well. 100, 176, 241, 182, 168, 21, 240. Oh, that's supposed to be a 243. Whoops, Vim script. We found that to be 243. We could double check. We could scroll up. 243. Yep, hit 243. So this is probably a sign to show that you should double check your numbers before you paste them. Make sure you have everything correct. Do those numbers say if they did? 243. Submit that. And look at that. We solved task 7. Thanks for watching. In this video, we had gone through the exploitation for task 7, involved manually and programmatically and reverse engineering for identifying what this process and C2 server is actually operating with, and then trying to leak some information through our directory traversal. Thanks for watching.